All right, this is Honors Algebra 2 Pre-Calc. We are doing 3.2 in Algebra 2, which is solving systems of equations by elimination. So you've already learned two methods, graphing and substitution in 3.1. We're now going to learn a third method called elimination. In Chapter 4, we're going to learn how to use matrices, which would be a fourth method to do this. So elimination is good for equations that have non-1 coefficients, meaning ones where there's no easy variable for substitution, and or equations that are naturally lined up for elimination. We'll talk about what that looks like in a sec. Elimination is bad for problems that are difficult to line up for whatever reason. Sometimes it's also bad for things that have really disgusting coefficients. I would say that things that have really horrible coefficients like decimals and really ugly fractions, I might not do elimination. So let's talk about what we mean to say line up. So I'm going to give you a fake example, right? So we're gonna talk about a 2x plus 3y equals 5, and we're going to talk about x equals negative 2y plus 3. Okay, so in this example, this is not currently lined up. What we mean by lined up is that all the x's are on top of the x's, the y's are on top of the y's, the equal signs are on top of each other, and the coefficients are on top of each other. So what's making this be not lined up right now is that this negative 2y is on the wrong side. So if I rewrite this instead, and I'm going to come over here and do this, I keep the 2x plus 3y equals 5. I'm going to add that 2y over. So I'm going to get x plus a 2y equals a 3. So now I have a situation where everything's lined up, right? My x's are lined up with my x's, so we'll just put, so x's are above the x's, right? That's right here. My y's are above my y's, there you go, right? My equal signs are above my equal signs, right? There's the equals. And my numbers are above my numbers, right? My constants are above my constants. So that's what we mean by lined up, okay? The next thing you're going to do is you're going to pick a target variable to eliminate. So when we say target variable, what you want to do is you want to, for this particular variable, you want to get the coefficients to be opposite numbers by multiplying or dividing the entire equation. Well, I noticed that I could probably eliminate x and 2x pretty easily by just multiplying the entire second equation by a negative 2. So what I'm going to do is I'm going to pick x as my target variable, and I'm going to multiply that whole second equation by negative 2. So what's going to happen is the top equation is going to stay exactly the same, so 2x plus 3y equals 5. And my bottom equation, which I'll do in green, is going to become a negative 2x plus, minus a 4y, my bad. I was going to say plus a negative, and then I ran out of room, equals negative 6. Okay, so remember, this was my target variable, right? This was what I wanted to eliminate, right? Well, sure enough, when I add straight down, right, I'm going to get 0, which eliminates my x. That's why it's called elimination, right? Minus y equals negative 1. I'm then going to solve for y, right? So see here it says solve for the variable that remains, which is going to give me y is 1. Once I know y is 1, I can substitute into either of the original equations. I'm going to pick the second one because I think it's easier. So x plus 2y, well, 2y would just be 2 times 1 equals 3. So x is going to be a 1 as well, right? So it doesn't matter if you eliminate the x or the y, you'll get the same answer. It's just sometimes one path is easier than the other. Another thing that you'll notice is that some teachers are going to, notice how I said that you wanted to multiply to get opposite coefficients, right, which is what I did right here. I got a 2x and a negative 2x. Some teachers are going to tell you to get the same coefficient, like a 2x and another 2x, and then subtract straight down. There's nothing wrong with that. It's the exact same operation. I just find that when people do that, they tend to make more mistakes with the other values, like they would subtract and accidentally get the wrong value out. So there's more human error when we make it subtraction. I would suggest that you make the coefficients opposite and then add. What do the weird cases look like? Well, the weird cases look the same way they looked when we did substitution in the last section. If all of your variables disappear, you don't just eliminate x, but you accidentally eliminate both x and y, then what's left is a lie, like 0 equals 5 rather, then that's going to be a no solution situation. It's going to be inconsistent. And if what remains is a truth, like 0 equals 0 or 10 equals 10, then the system has infinite solutions of a particular form, which you'll have to find, just like we did with substitution, and it would classify as consistent dependent. So we're going to walk through some examples, a bunch of these, and then for the first couple examples, I'm going to require that you solve with elimination, not because I would make you do that on a test, but because it's good that you get practice using all these methods, and then later I'll let you choose which of the methods you want to use that we know so far. All right, cool. So in example 1, I would say that the natural choice is to eliminate the x. Here's the reason. So I'm going to say that my target variable should be the x. everything's lined up. I have x over x, y over y, equal sign over equal sign, and n number over number. But the x's have coefficients of 2 and -4. That's easy. I can just multiply the top equation by 2 and I'll have opposite coefficients. If instead I chose to eliminate the y's, it's not wrong, it's totally fine, but if you chose to eliminate the y's, you're going to have to get a common multiple of 35. So one of those is going to be a positive 35 and the other is going to be a negative 35, and you're going to get much larger numbers. So in this instance, it seems much more sensible to say, hey, I'm going to eliminate the x's by multiplying the entire top equation by 2. So what's going to happen is my top equation is now going to be a 4x plus a 10y equals 30. The bottom equation hasn't changed. It's a negative 4x plus 7y equals negative 13. Right? When I add straight down, the x's get eliminated, which was what we expected when we chose x as our target variable. I get a 17y equals 17. So when I solve for y, I get y is 1. I then pick either of the equations to plug into. I'm going to pick the first one, 2x plus 5y, which would just be 5 times 1 equals 15. So 2x is 10, which means my x is 5. I can either write my solution like this, where I list x and y separately, or I can write it as 5, 1. Make sure you do x, y. When I'm asked to classify, it's going to be consistent because it has a solution, independent because the two lines are not the same line, right? It has a specific spot where they run into each other, okay? So going to the next slide, you're going to try a P1. So again, you can choose to eliminate either variable here. Go ahead and pause me if you want to do this on your own. Here, I would argue that yet again, there is an easier candidate. So my choices are either to multiply the bottom equation, sorry, didn't mean to write, to multiply the bottom equation by a positive 2, which would give me -6 and positive 6 for the r coefficients. Or I could multiply the entire bottom equation by a -7 to make the s's cancel. I think the more logical choice is to multiply by the positive 2 to make the r's be the same value. So I'm going to get a -6r plus 2s, sorry that my s's kind of look like 5s, equals -12. And the top equation didn't change. It's a 6r plus 7s equals -15, right? So when I add straight down, the r's are going to cancel because I chose to eliminate the r's. I'm going to have a 9s equals -27, so s seems to be a -3. Once I know that s is a -3, I pick either equation to find r. I'm going to go ahead and pick -3r plus s equals -6. So that's -3r minus 3 equals -6. -3r equals -3, so r is 1. So again, I can either write my solution this way, or I can write it as an ordered pair. The only word of caution I'd give you is that ordered pairs are typically x, y. So the other way you could write it is you could write it r, s equals 1, -3. If you're not using x and y, you should note which is which, okay? So in this situation, this answer is better because an ordered pair is typically x and y. An ordered triple is usually x, y, and z. If you're using different letters like a and b or r and s or p and q, you should really assign which one's which, okay? And when I'm asked to classify, this is going to be consistent, which means that it has a solution, independent, which means that the two lines are not the same. Okay, consistent, independent. All right, let's go to another one. All right, so first glance, the first thing you might notice is, hey, that's weird. Not only is it lined up, but these equations look a lot alike, right? So I'm going to go ahead and pick my target variable to be my y. So I'm going to multiply by a -1 on top to make this a -2x, my bad, sorry. Come on, brain. -2x minus 5y equals -12. And on the bottom, I have the original 2x plus 5y equals 15. And remember my goal, I chose to eliminate the y's, which is great, except an interesting thing's going to happen when I add straight down. Both of these are going to get eliminated, right? -2x and 2x are going to get eliminated too. So I'm going to get 0 equals 3. That's a lie. What that means is that there is no solution. And if I'm asked to classify this, this would be inconsistent, right? Because the word consistent means has a solution. This one does not have a solution, so it would be inconsistent. So that's one of those special cases. All right, let's try P2. Okay, so you're probably noticing the same trick with P2, right? So I'm going to go ahead and choose to eliminate the x's this time. So I'm going to multiply by a negative 1 up top. I'm going to get a negative 6x plus a 2y equals negative 9. My second equation stays the same as a 6x minus 2y equals 7. When I add straight down, I end up with a 0 equals negative 2, which is a lie. So there is no solution. And if I were asked to classify this, which I am, it would be called inconsistent. Now, if some of you are thinking, I can see that with my eyeballs, why would I do any math? That's totally fine. You can explain that you can see it. You can say, hey, I noticed that these graphs have to be parallel lines because they have the same slope, like the same rise over run if you solve for y, but different y-intercepts, and that means they have no solution. That would be fine. That's not cheating, right? All right, so let's talk about E3. So E3's got some decimals, which is not super awesome and fun, but we'll deal with it. So when I go to do E3, the first thing I'm going to suggest is that I don't really want to deal with the 5 and the 7.5, but if I go ahead and try to eliminate the x's, there's a pretty easy common multiple of 6 here. So I'm going to pick 6 as my target, which means I'm going to multiply the entire top equation by a positive 3 and the whole bottom equation by a negative 2, right? Because that'll give me a 6 and a negative 6. So the top is going to end up having a 6x plus 15y equals 45. The bottom is going to end up being a, sorry, I didn't mean a negative 2. I think I even said positive 2, but anyway, meant a positive 2. My bad. So it's going to be a negative 6x minus 15y equals negative 45. And when I add straight down, sure enough, I suddenly get 0 equals 0, which is true. So what that means is I'm going to have one of those situations where there are infinite solutions. I just need to find the form of those solutions. So I'm going to go ahead and pick an equation, the one that I think is easier to solve for y. So I recognize that this is a 5y equals negative 2x plus 15. So that's y equals negative 2/5 x plus 3. So there are infinite solutions of the form a, because if I plug in the letter a for x, then the y would be negative 2/5 x plus, or sorry, a, my bad, plus 3. Okay, and that would mean that this classifies as consistent dependent, because these are the same line, okay, consistent dependent. Now, if you had chosen, instead of solving for y, because there's almost always somebody who does, if you had said, hey, I really don't want to solve that for y, what if I solve it instead for x? If you'd gone the other direction and solved that for x, you would have gotten 2x equals negative 5y plus 15. You would have gotten x equals negative 5 halves y plus 15 halves. And there's nothing wrong with that. And so then, instead, your infinite solutions would look like this. You'd plug the a in for the y, because that's the thing you solve for x. And then in terms of y, your x was negative 5 halves of the y, which would be a, plus the 15 halves. Those are the same answer. Either of them are right. If you chose to use decimals instead of fractions, that's fine too. Remember, it's my job as your teacher to spot that your answer is also right. That said, I think that as a general rule, it's easier to solve for y, because that's what we've been doing for years in math anyway. All right, so let's try a P3. Again, you're going to go ahead and pause me if you want. So I'm going to choose to get rid of the y. I'm going to pick y by multiplying this by a negative 4. But I very quickly realized that this is exactly the same equation with opposite signs, right? As soon as I realized that, oh, hey, look, that is the same exact equation. I just have all opposite signs. When I add straight down, I get 0 equals 0, which is true, right? So what that means, oh, my bad, didn't mean to go back, guys. Okay, so what that means, I'm going to pick the easiest equation to solve for y, which is totally this one. I get y equals negative 2x minus 4. What that means is that there's infinite solutions of the form a, comma, negative 2a minus 4, right? And again, if you'd gone the other direction and chosen to solve for, if you'd chosen to solve instead for x, then you would end up with something that looks like this. So just if you'd solve for x, it would be negative. Okay, so you would get negative 1/2 a minus 2, comma a, if you'd solved the other direction. And that's fine too, it's the same answer. If you're asked to classify you're going to say that this is consistent, because that means it does have a solution, right? Dependent, right? Because it's the same curve, all right? Cool. So let's do an E4. So the trap with E4 is that this thing's not lined up. So before I can do anything else, I need to move some stuff around and make this a 2x minus 4y equals a negative 20, right? And then I still have this thing on top, which is a 5x plus 3y equals 2. Now it's up to you. If you pick x to eliminate, you need a common multiple of 10, right? The least common multiple of 5 and 2 would be 10. If you pick y to eliminate, you'd be looking at a 12. Now there are a couple ways around that. The other option is that if you wanted, you could cancel a 2 out of this entire second equation first, because you could actually divide all of these guys by 2. But I'm going to go ahead and pick that I want to eliminate the y's. So in order to eliminate the y's, I need a 12 and a negative 12. I know they're 12s because the least common multiple of 3 and 4 is 12. So I'm going to multiply the top by a 4. I'm going to multiply the bottom by a 3. And what's going to happen when I do that is I'm going to get 20x plus 12y equals 8. And I'm going to get 6x minus 12y equals negative 60. When I add straight down, I'm going to get 26x. The y's cancel. 26x is going to be a negative 52, so x is a negative 2. Once I have that x is a negative 2, I plug back into either equation to find y, right? So I'm going to pick this one because it's already kind of solved for y. So 4y equals 2 times that negative 2 plus 20. So that's 4y equals 16. Y is a 4. So I can either write my answer as negative 2 comma 4 or separately like these two. So when I write my solution, I'm going to write it as either x equals negative 2, y equals 4, or negative 2 comma 4 for x comma y. And when I classify this had a solution. They were two different lines. That is consistent, independent, because they were different lines, right? Independent. That's not how you spell that. Come on, brain. Okay, consistent, independent. Cool. Moving on. Give P4 a try. Notice again that it is a bit of a trap. Things are not lined up. Feel free to pause me if you want. The first thing I'm going to do is switch the order of these so things are lined up. Remember that negative is going to stay with the 4x. The positive is going to stay with the 2y. So in this situation, I'm going to go ahead and pick the y's, which means I want a common multiple of 6. So I'm going to multiply the top by 3 to get a positive 6, and I'm going to multiply the bottom by a negative 2 to get a negative 6. So the bottom is going to end up being a 10x minus 6y equals negative 46. The top is going to end up being negative 12x plus 6y equals 54. When I add straight down, I get negative 2x, the y's cancel, and that's going to be a positive 8. So I get negative 2x equals 8, which is x equals negative 4. When I go to plug into either equation, doesn't matter which, I'm going to pick this one, 2y minus 4x equals 18. Right, I'm going to go ahead and plug in there. So I get 2y plus 16 equals 18. 2y equals 2, y equals 1. Cool. My solution can either be written the way I just did with the x and y labeled, or I can write it as x comma y. And when I'm asked to classify, this is consistent because it has a solution, independent because the two lines are different curves, right? Cool. Let's do an E5. So we're going to do an E5 and I think a P5 where I ask you to use elimination, and after that we'll stop this video. And then when we come back, you'll be able to solve in any one of the methods you choose. So again, this is one that's not lined up, right? The first thing I'm going to do is line this up. So 2x minus 4y equals 5. And for this one, I'm going to subtract the x over. So negative x plus 2y equals 8, right? So I'm going to go ahead and I choose the x to eliminate. So I'm just going to double the bottom, right? And that's going to give me a negative 2x plus 4y equals 16. And I didn't change the top at all, so it's a 2x minus 4y equals 5. And when I add straight down, I seem to get 0 equals a 21, which is a lie. So there's no solution. And this is inconsistent, right? Because consistent means you have some kind of a solution. So no solution at all would be inconsistent. All right, and here's your P5. You go ahead and try it. You can pause me if you want to do it on your own. I'm going to go ahead and move my 10x over by subtracting. And I'm going to move the 30 over by subtracting. I suppose I could have done this faster by just moving the 4y, but oh well. And then this one's already lined up, so it's a 5x minus 2y equals 15, right? So I'm going to choose to eliminate the y's. So I'm going to multiply the bottom by 2. And when I do that, I seem to get 10x minus 4y equals 30. The top was a negative 10x, a plus 4y, and a negative 30. So that pretty clearly tells me I get 0 equals 0, which is true. So that's not, doesn't mean I'm done, right? It means that there are infinite solutions of a particular form. So I'm going to solve either one of these equations for whatever's the easiest to solve for. Let's see. I'm just going to we'll solve the second guy. So I'm going to go ahead and subtract the 5x, so negative 2y equals negative 5x plus 15. Divide everybody by negative 2. And I'm going to get y equals 5 halves x minus 15 halves, or the decimal equivalent. So my answer is going to be that there are infinite solutions of the form. And because I solved for y, I'm going to plug in a for x, and I'm going to make my y that 5 halves a minus 15 halves. Again, you could have solved the other direction, but I'm just going to go with that for now, and hopefully you've picked up from earlier in the video how to do it. And when I classify that, this is going to be consistent, which means there is some kind of a solution. Dependent, meaning these two are the same line, okay? Cool. All right, and then we'll stop this video here.